Hello, year 11s. In this question, I'm going to go through question number 1, which is on forces. This question comes from the AQA specimen paper released in 2018. Question 1. 4 students tested their reaction times using a computer program. When a green light appeared on the screen, the students had to press a key. Table 1 shows their results. Student, boy 1, 2, girl 1 and 2. Reaction time in seconds. So they've done it 3 times and their mean reaction time has also been given. Question 1.1. What is meant by reaction time in this experiment? So when a green light appeared, they are saying when a green light appeared on the screen, the student had to press a key. So the reaction time is the time it took from seeing the green light to pressing a key. Question 1.2. Boy 2 had an anomalous result in test 2. Suggest a reason why. So when you look at boy 2, test 2, this appears to be the anomaly, which is 0.47. Suggest a reason why. So you're giving a possible reason, right? He could have been distracted. Question 1.3. Give one conclusion that can be made from the results in table 1. So looking at the results, you can see that the boys' mean reaction times is lower than the girls. So that's our first, right? This is lower compared to the girls. And if you look at the individual reaction times, 0.28, 0.27, 0.26, so it seems to be improving. 0.28, 0.22, 0.31, 0.29 and 0.27. So in every case, the reaction time is also improving. So let's try either one of them, or they're only asking for one conclusion, but I'm going to write both of them. So the first one, right? Boys have a shorter reaction time compared to girls. The second conclusion that we can draw is reaction time improves with practice. Next question. Question 1.4. Suggest further evidence that could be collected to support your conclusion. Suggest further evidence that you could collect. So what can you do to support your conclusion? Right? We could collect more data, right? So rather than doing it 3 times, you can actually do it 10 times, or collect from a larger sample size. Because we concluded that boys are faster than girls, we only tested 2 boys and 2 girls. Maybe we can test 10 boys and 10 girls. Or what we can do take more repeats or readings per person, which is very similar to what I've said, to collect more data. Reaction time is important at the start of a race. Table 2 shows the time taken by a boy to run different distances. So 100 meters is 12.74, 200 is nearly double that, and 800 is 139.46. Reaction time is more important in a 100-meter race than in an 800-meter race. Explain why. Why is it more important in a 100-meter race? Okay. Reaction time will have less effect as distance increases. Because we are trying to explain for the 2 marks, we need to expand that further, because it is a smaller proportion of the total race time. So think about it, in a 100-meter race, if all it took was 12.74 seconds, and let's say it took 1 second to react, so he ran for 11 seconds, right? But the reaction time is not going to change. Even if he's running 800 meters, it's still going to be just 1 second out of nearly 140 seconds. So the proportion of the reaction time is much smaller in an 800 meter than in a 100-meter race. Next question. 2 girls, A and B, ran an 800-meter race. Figure 1 shows how the distance changed with time. So here you have the graph. I should be able to fit that in. Yes, right. So we have a distance time graph. The distance is given in meters, starting at 0, and it goes all the way to 800. So that's where the race is actually ending, and the time in seconds, and it goes up in 20s. So looking at question 1.6, compare the motion of runners A and B, include data from figure 11. So we have to include data from the graph, and we are trying to compare the motion of the runners A and B. Right? So when we are describing the motion, we need to use specific words from the distance time graph. Right? So looking at this graph, because it's a straight line, right, I can say A has a constant speed at the start of the race, where it's a straight line, whereas B doesn't have a constant speed. Right? So let's write down these points bit by bit. So A, so let's first point, A starts at a constant speed, right? So I can if I use a ruler, I can confidently say, if I put a ruler, that it's a straight line right up to about 60, right? So up to there, it's actually a straight line, and then it starts to curve, right? So, and I can work out this constant speed, right? The constant speed would be the gradient distance divided by the time. So the distance is about 440. So right about there, 440, and that will be the 60. So which is the gradient. So 440 divided by 60, it should give me an answer of, if I bring the calculator, 440 divided by 60 gives me 22 over 3. Change that to decimal, 7.3. 7.3 meters per second. Let's get rid of the calculator. Right. And then what happens? The gradient is actually getting smaller. It's getting less steep for A. So that's because the runner is actually slowing down. Right. So second point, A then slows down from 60 seconds. Looking at runner B, let me see if I can fit this in. Yeah. Right. So looking at runner B, they actually have a lower speed, right? Because the gradient is lower than this point, it's less steep, right? So the gradient for B is lower at the start so B starts at a slower speed. Remember the gradient, and this is a worthwhile note to make. Gradient, which is the y over x, equals the speed, because y value is the distance and the x value is the time. So let's have a look at the next point. For 6 marks, we should be writing more. So point number 4. So what is happening to the gradient of B? It's actually getting more and more steeper as the race progresses. So the gradient of B increases, so B accelerates. Right? So these are keywords that I'm using because we are trying to describe the motion. Speed, accelerates, right? Those are keywords that I'm referring to. Right? And when we look at the graph, runner B is actually overtaking, right? So at 700 meters, they're roughly, right, that's about 110, and that's 114. right? After about 114, B actually overtakes A. So 5. B overtook A at 700 meters or 114 seconds. Right? So when we look at the overall speed of B, right, because runner B actually completed the race before A, right? So at about 130, it will be 126 seconds, runner B has actually finished the race, whereas it took 160 seconds for runner A. So 6 point. B has a greater top speed because the maximum gradient is greater. The reason I'm saying that is when we look at the line steepness, B has a much more steeper line at any point. And the last point, B won the race in 126 seconds, or you could say beat A by 34 seconds. How am I getting 34? Remember, A took 160 seconds minus the 126. That should give me 34 seconds. And one additional thing I can work out is the average speed of both these runners. So average speeds of A equals, so 700 divided by 126. So let's bring the calculator up again. $700 divided by 126, that gives me 50/9. That's 5.5 meters per second. Runner B, oh, that's actually runner B. I used the data incorrectly. So this will be runner A. Took 700 seconds, sorry, 700 meters, and the time was 160 seconds. So 160. So 700 divided by 160. That gives me 4.375 meters per second. So the average speed of B is actually bigger than the speed of A. Question 1.7. Use figure 1 to determine girls B speed at 60 seconds. Show how you use the graph to obtain your answer. So looking at the graph, we are looking at girl B at 60 seconds. B at 60 seconds at this point. What would be girl B's speed at 60 seconds. How do we actually find it? We can determine that by drawing a tangent. So how do we draw a tangent? A tangent is drawn, first mark the time, and then you are going to draw a triangle as big as possible, right? But that length, so if I go from 1 to, if I go all the way, right, I'm going 20 seconds on that side, and then I'm going 20 seconds on this side, so it's of equal length, and then so the total x value is 20, 40, so I've gone 40 and 40 on both sides, so the total is 80 seconds. So here it's starts at 40 meters, it's in the fourth box, and 450, 60, 70, 470. So the difference would be 430 meters. So gradient equals y over x. So y value was 440. 430, divide that by 80. So 430, divide that by 80. The calculator is already there. So 430, divide that by 80. That gives me an answer of 5.3. 5.375 meters per second. I can round it off to 5.4 meters per second. That's the end of question number 1, and that's the end of the video. Thank you.